So the next thing now we have to do is to measure for the what? Links or the stirrups. Now if you look at this drawing, from the section through 1, which is here, you can see that this is our what? Column. When you what? Cut it, right? It is a what? Square, spanning what? 230 mm by what? 230 mm. Let me zoom in so that you can see it better. So spanning 230 by what? 230 by what? 230 mm. So now what we are now going to be doing now is to determine the length of reinforcement that is going to go around the 4 major reinforcements in our starter bars is to what? Minus concrete cover from both sides on the length side and concrete cover on both sides for the what? Width sides. Then whatever we get, we'll multiply the length side by 2, multiply the width side by 2. It will give us the length of the reinforcement round. We're now going to be adding extra for this bend here and for this bend here. I hope that's easily understood. So mathematically, what that implies is that if the concrete cover for our stirrups is 25 mm, so for the length side, which we have as 230, we'll now minus 25 mm from both sides. That will give us 180. So it means that from here to here is 180. Similarly, for the width side, from here to here is also what? 180. So what can we do now to get the length of the reinforcement round? We'll now multiply the length side by 2 and the width side by 2 and add them together. So 1080, since they are the same length, you can multiply by 4. It will now give us what? 720. It means that the length of this reinforcement round for the stirrups is what? 720. We'll now add bend. So there's a formula for calculating the bend of your stirrup, and that formula is what? 12D. So what is the D? The D is the what? Dimension of the what? Reinforcement. If you look at here in our section, this line here is telling us the placement of our what? Links or our what? Stirrups. And as you can see, it says 7Y10 00 links, 200 was center to center. So there's no need to start calculating the quantity of what? Links that would be along this length of reinforcement from here to here, because it's already stated in the what? Drawing. But if you don't know how to, this is what you will do. You have to determine what is the distance of this dimension that they have given you. That's from here to here. You know it is not given. You have to look for it from here to here. Once you have that, you will divide it by your what? Center to center spacing. Whatever you get is the number of what? Links you are going to be having within this what? Length. But that is not the case. We are already giving it the number or the quantity as what? 7. So we are just going to be doing it direct. So now, since we know that the quantity of links along this starter bar is 7 in number, what are we now going to be doing? We are going to be multiplying the length of our stirrup by the quantity of the links in one number of column type 1, and then we'll now multiply it by the number of column type 1 we have. So it's kind of the same way we did the measurement for the starter bars. It's just that this time it is the what? Links. So now let's begin our what? Calculation. So if you can see this drawing, we want to determine what is the length of the reinforcement as we said before. So what we're going to be doing now, since we know that from here to here is 230, from here to here is 230, we're going to be what? Minusing what? Concrete cover from both sides. So we'll now say concrete cover is equal to what? 25 mm. So we'll now do this for the length side. We're now going to be having what? 230 will less what? Concrete cover from both sides, which is what? 2 by 25. That is what? 50. So when you minus that, you are going to be having what? 250 for the length side. So similarly for the width side, Sorry, this is supposed to be 230, not 200. 230 minus, this is supposed to be 180. Sorry. So similarly for the width side, we're going to be having what the width is was 230 with less concrete cover, which is 2 by 25. That's about 50. So when we less that, we're going to be having what 180. So the length side is 180, the width side is 180. How many lengths do we have? We have what 2 length sides and we have what 2 width sides. So what we can now do is this: we can now add, since it's a regular square, we can now do this, add these two together. So 180 plus 180 is what 360, meaning that the length for this reinforcement like this, for just this side, is what 360. So we're going to be multiplying it by 2 to cater for what this side and what this side. So 360 multiplied by 2 is equal to what 720. So it means that the length of the reinforcement like this is 720. We're not going to be adding extra for our what bend. So we'll now say add bend, and I said that the formula is for 12D. So the bend is on 2 sides, so it is going to be what 2 by 12D. So that's 2 by 12. And what is D? D is the what diameter for our what bar, which is what 10 mm. So when you do this math, 2 times 12 times 10 is equal to what 240. So 240 is the total bend by adding for the what bend in the links, meaning that one bend is 120 mm and the other is what 120 mm. So when you add these two together, 720 plus 240 is equal to what 960. If you look at the drawing, column type 1 down to 4 are the same dimension. Now look at this drawing through section 1 for column type 1. It is 230 by what 230. Similarly for column type 2 through section 3, 230 by what 230. Similarly column type 3, 230 by what 230. And similarly column type what 4, it is 230 by what 230. So now the only ones that are different is column type 5 and 6. Column type 5 was 300 by what 300, and column type 6 is what 230 by what 300 and what 81. So now with this we can now book for column type 1 to what 4. So we'll start with what column type 1. So for column type 1, the length of the reinforcement that we've calculated for the links is what 960, which is what 0.96. And they said that the number of links that we are going to be needing in that part of the starter bar is 7 in number, as I've shown you in the drawing here. This is where the links are going to be what placed, and the detail says it is what 7 in number. So we'll now multiply it by what 7, and then multiply it by the number of column type 1 that we have, which is how many in number. We counted it as what 7 in number when we're dealing with our what starter bars. So multiply by 7. So when you do this, 7 times 0.96 is equal to what 47.04. So we'll now do the same thing for column type 2. So for column type 2, we'll do the same thing. 0.96 multiplied by what? 7 number of links multiplied by what? The number of column type 2 we have, which we counted as what? 8. So 8 times 7 times 0.96 is equal to what? 53.76. So we'll now do for what? Column type 3. So for column type 3, 0.96 multiplied by what? 7 number of links multiplied by what? The number of column type 3 we have, which we counted as what? 4. So when you do the maths, 4 times 7 times 0.96 is equal to what? 26.88. And then column type 4, 0.96 multiplied by what? 7 number of links multiplied by what? The number of column type 4 we have, which is what? 3 in number. So when you do the math, 0.96 multiplied by 7 multiplied by 3 is equal to what? 20.18. 20.16, sorry. What I'm just going to do here now is to add all these ones together. So 47.04 plus what? 53.76 plus 26.88 plus 20.16 is equal to what? 147.76. So this is the total length of what? Y10 reinforcement needed to cater for the links from column type 1 down to column type 4. So what is left now is for column type 5 and column type 6. So we are now still going to be using the same approach. We'll determine what is the length of the reinforcement for the links for column type 5 and what? 6. So for column type 5, the dimension is what? 300 by what? 300, meaning that this is what? A square. So let me use another approach different from how we calculated for the length of the links for column type 1 to what? 4. So what I can now do is this. You know that what we did in the first one, we first determine the length of the reinforcement for the length side and the width side, and then we multiplied each by what? 2, and then added them together. That's for the total length of reinforcement for one link, that's for one stirrup. So now for this case, we know that the four sides of a square are what? Equal. So what are we going to do now is this. We're now going to determine the length of what? 1. Since we know that since here is 300 and here is 300, meaning that if we get the length of this side, it is going to be equals to what? The length of this side, and what? This side. So what we'll just do is to get the length of 1 and then multiply it by what? 4. Let me just add the what? The bend. So now we can now see, we know concrete cover is equal to what? 25 mm. So we'll now see the length is what? 300. We'll now less concrete cover, which is 2 by 25, and that will be what? 50. So when we less that, we are going to be having what? 250 mm. So now this 250 mm is the length of the reinforcement for just one side. We'll now multiply it by what? 4. So 250 multiplied by 4 is equal to what? 1000. So the length of the reinforcement round is 1000. So we're not going to be adding what? Our bend. So our bend is, we said it's what? 2 by 12 by D, which is what? 10 mm. So 2 times 12 times 10 is equal to what? 240. So we'll now add this 240. So when you add this together, you're going to be having 1240 mm as the length of your reinforcement for the what? Stirrup, for one stirrup in column type what? 5. So we'll now do the same thing for column type 6. So as you can see for column type 6 is different from column type 5 and it's different from column type 1 to 4. So as you can see, this is a rectangular shaped what? Column with a dimension of 381 by what? 230. So now what we're now going to be doing is this. We are going to be using the same approach to determine the length side of the reinforcement for the link, and then we're also going to be finding for the width side of the reinforcement for the links, because this is a rectangle. Why are we finding for the length and the width side? Because the two opposing sides are what? Equal. So it means that if you can get the length of this side, we can multiply it by 2 to cater for this side and this side. Similarly, if we get the length for this side, we multiply it by 2 to cater for this side and what? This side. So when we add them together, we'll get the total length of the reinforcement round. So what we can now do is this. Let me just say length side, width side. So our length side is what? 381. So we'll now less what? Concrete cover, which is 2 by 25, and that is what? 50. So our width side is what? 230. We'll now less concrete cover from both sides, which is what? 50. So when you do the math, you're going to be having what? For the length side, 381 minus 50 is equal to what? 331.5. And then 230 minus 50 is equal to what? 180. So we're going to be multiplying this by 2, multiplying this by what? 2. So what do we have? So this 3301.50 is the length for the what? Reinforcement for the longer side, while 180 is the length for the reinforcement for the shorter side. So I'm multiplying it by 2 to cater for this side and to cater for what? This side. So 331.50 times 2 is equal to what? 663. So 663 is the length of the reinforcement for this side and for this side. Similarly, 2 times 180 is equal to 360. So 360 is the length of the reinforcement for this side and for what? This side. So we'll have to add the two of them together. So therefore 663 plus 360 is equal to what? 1023. So this is the length of the reinforcement round. So we're not going to be adding our what? Bend. And our bend the formula is what? 212D. 2 by 12 by what? D. So 2 times 12 times 10 is equal to what? 240. So when you add these two together, what are we going to be having? 1023 plus 240 is equal to what? 1263. So this is 1263 millimeters. So this is the length of one stirrup in column type 6. So with this now, we can now start measuring the total length of the reinforcement needed to cater for the stirrups for both column type 5 and what? Column type 6. So now let's record for what? Column type 5. The length of one of the stirrup was 1240. Convert that to meters, that's 1.24. And then we'll multiply it by the number of what? Stirrups that we have in the what? Starter bar, which the drawing has given us as what? 7 in number. So if you look at this, this is column type 5, and you can see this is the placement of the links, and they have given us as what? 7 in number. So 1.24 will multiply it by what? the 7 number of links in column type 5, and then we'll multiply by the number of column type 5 we have, which is what? 2 in number. So when you do the maths, 2 times 7 times 1.24 is equal to what? 17.36. So this is going to be what? 17.36, and then you close. We'll now do the same thing for column type 6. For column type 6, what did we measure as the length of our column type 6? We measure this as what? 1263. So it means that this is going to be what? 1.26 multiplied by the number of links we have in column type 6. Now if you look at this drawing for column type 6, the detail says that the number of links are what? 7 in number. So we're now multiplied by what? 7, then multiplied by what? The number of column type 6 we have, which is what? 1. So when you do the maths, 7 times 1.26 is equal to what? 8.82. So we can now add these two together. 17.36 plus what? 8.82 is equal to what? 26.18. So the total length of reinforcement needed for the links for column type 5 and 6 is 26.18 meters, and you know that we've already done column type 1 to 4, and we got the total as 147.76 meters. So we're going to be adding this 147.76 meters with our 26.18 to get the total length of the reinforcements that we're going to be needing for the what? Stirrups. So we'll now say summary. (26.18) plus 147.76. So when you add them together, you are going to be having 173.94. So this is the total length of Y10 reinforcements that you are going to be needing to construct all the links from column type 1 down to column type 6. But we don't need this value in meters. We need to convert this to what? Tons. And how do we convert this by tons? We have to first convert it by kg in kg by multiplying it by our what? Constant. So what is the constant for Y10? That was 0.617. So we'll now say 2 kg will now become what? 173.94 multiplied by what? What's the constant of 10 mm reinforcement? And 0.617. So when you do your maths, 173.94 times 0.617 is equal to what? 107.32. So we'll not divide this by what? 1000 to give us in what? Tons. So to tons, it will be what? 107.32 divided by what? 1000, and that will be equals to what? 0.107. So we're going to be needing 0.107 tons of Y10 reinforcements to be able to what? Construct all the stirrups needed for our what? Starter bars. I just hope that's easily understood. So this is the quantity of reinforcement we're going to be needing for all the what? Links in the what? Starter bars. So we're going to be using the same approach when we get to the superstructure for calculating the reinforcement inside the columns and the links inside the columns. So with this, we've come to the end of today's video, guys. I hope you derived adequate knowledge from it. Please, if you did, do not forget to like, share and subscribe to this channel. because it helps the channel grow. Thank you, and we'll see you in our next video.